Perfect.
Okay.
A very warm welcome to the last session of today, of this full day. I've enjoyed it very much, hopefully you as well. This talk is about DevOps and DevSecOps. My name is Peter Mosmans, said in Dutch. In English it would be Peter Mosmans, and I'm my house sitter. For those of you unfamiliar with house sitting is when people go overseas on holidays, sometimes for a few days, sometimes for a few weeks, sometimes for a number of months, and you get to care for their property, for their pools, for their pets, mainly dogs to be honest. I've been fortunate enough to do that all over the world, mainly in Australia, and you get to know lots of different cultures. You get to know lots of different pets as well, lots of different breeds. And for me, when I started house sitting, I'm originally from the Netherlands, Amsterdam, and I wouldn't say it's not a trustworthy city, but trust is something you have to earn, you validate. So when I started house sitting, I started about 10 years ago in Australia. Somebody asked me to house sit, and the only thing he knew of me was my name. He didn't know my full name, he didn't have my background check, not my password, yet still, he trusted me with his most valued possessions, not only his house, but also his two beautiful Dobermans. And I was so taken aback by that somebody who I didn't know, he didn't know anything about me, he still trusted me. And my first initial reaction was, because somebody trusts me, I like to reciprocate the trust. And I'm maybe naive, maybe optimistic, but I think if you trust people, the natural reaction of people is to give that trust back. So yes, even though the dog didn't trust me in the beginning, after a while we became best friends. But that fact that trust can be reciprocated, that's the natural reaction, and I think that's across all cultures. That's a human trait, or at least I hope it is. Besides a house sitter, I also do work for PluralSight. I'm an author there. I offer courses on secure coding, on pen testing, and also on threat modeling. And I'm a penetration tester, a fun job. Penetration tester, I mainly work in the web application space. It's a huge field. You have crypto, you have physical stuff, social engineering, reverse engineering, hardware. I mainly do web applications. I've done it now for about 20 years. Also for a lot of different companies around the world. And again, it's a great way to get a peek behind the curtains of companies. To see how their level of security is, to see how they work. And from that perspective, I made this presentation as me as a penetration tester over the years. The companies I mainly work for, we use the penetration testing execution standard as a standard workflow. There are a lot of different standards, certifications as well for penetration testers. Some good, some bad. I don't know, I can't say anything about that, to be honest. The standard we work with is mainly a workflow to give our clients a bit standard that they know what to expect, which threat model we use, which kind of threat levels we use, so it gives them kind of a leeway in order to see what they can expect. Basically, the first phase is scoping. That's where you go to a client, the client says, I want to have this and this tested. This can be as simple as an API endpoint or a static website, or sometimes the whole company. That's where you decide upon the boundaries of the test and the time box, the way how you're going to test it. When all the contracts are signed, because I do legal penetration tests, we always have a disclaimer, a non-disclosure agreement most of the time as well, but also the get out of jail free cards, which are very important, the waivers. When we start, then we start with the reconnaissance phase. You try to get more information about the target that's in scope. That can be using secondary sources or just simple things like port scanning, IP address scanning, in order to get a better picture of your target. Depending on the size of the penetration test, we perform threat modeling. Now you have threat modeling for applications, which is for the biggest part, I think, pioneered more or less here at Microsoft. Threat modeling for penetration testers is similar. And is everybody here familiar with threat modeling? It's a way of systematically listing all threats for a given target, in this case the target and scope. Then you perform the vulnerability analysis. This is what most people see as penetration testing. You try to poke the target, you try to find weaknesses, vulnerabilities, and then you try to exploit them in order to see whether the vulnerabilities are really there or not. When you exploit a vulnerability in a target, depending on the target and the penetration test, you try to get a foothold, you try to move through the target and try to find the crown jewels of the company. What the objectives are of the penetration test. And finally, one of the most important phases, obviously, the reporting. The client, you want to show the client exactly what was wrong, so to speak, what you found, and you give them a list of mitigations so that they know what kind of risk they're currently under. Now, arguably, the most important thing of penetration testing is scoping exactly what you want to have tested, because that really influences the ultimate goal, the ultimate report. Another fancy word for a penetration tester is hacker, ethical hacker. You have the standard white hat hacker, and you have the black hat hacker. Characteristics of the white hat hacker, it's legal. You always work with signed documentation, and depending on the jurisdiction, on the country, you need to have several agreements. Sometimes you traverse other people's networks, they also need to sign off the waiver so that you're, when something goes wrong, I have experience with those cases, and that you actually can show the waivers, see I'm actually allowed to do so, and then the people let you go, in theory. A white hat penetration test, a penetration test performed by a white hat hacker is initiated by the client. The client actually approaches you and asks you, can you perform this penetration test? Another characteristic of a white hat penetration test would be that it's time boxed. Penetration test costs resources, time costs money, therefore there's always a limited budget available in order to do the penetration test. And again, the limited scope. Normally that scope is set beforehand, but sometimes when performing the reconnaissance phase, you find out about more targets. Sometimes they actually be added to the initial scope, depending on the client and the size of the penetration test. But usually that scope is already set and really boxed in. The scope is really important. Now then, the black hat, the adversary. Characteristics, it's rogue. There aren't any signed waivers. That person or that persons, that group of people, can do whatever it wants in order to gain access to the target. It is not initiated by the client, it is initiated by the hacker. And when I say hacker here, or black hat hacker, this could be a nation state, this could be a huge group, this could be somebody living in somebody's basement, just trying out things for fun, but somebody who is not doing any legal stuff. But he's the one or she is the one actually initiating the penetration test. Usually it's not time restrained. Again, depending on the group you're facing, the country, the people, there are obviously limits to what we as physical human beings can do, but that group of people can put any resource as available onto the target in order to find vulnerabilities. And anything is in scope. Again, anything. And that's the biggest difference of outcomes between white hat penetration test and black hat penetration test is the scope. What are other factors affecting outcomes of tests? During the scoping phase, when you talk to a client, usually they want to have several objectives. Say they want to see how their incident response team responds. They want just to see whether all the processes that are in place work. Another objective could be, we have this set of rich data and we don't want anyone touching that data. So the only objective is, can a penetration test access that data, yes or no, in this given time frame, given this scope. Another objective could be, does it withhold a denial of service attack from such and such, with such and such resources. Then there's obviously time. The longer the penetration test, the more vulnerabilities you will find. And again, the scope. This really affects the outcome of a test. Therefore, are the results of a valid white hat penetration test realistic? You always find some vulnerabilities. Are there any people here who have had penetration testing companies test the security of their services? And did in any case the penetration test didn't find anything? It's impossible. You always find stuff. Whether you find just pennies or real money, that's where the difference is. By the way, if you have any questions, remarks, please feel free to just ignore me and raise your hand. Let's move to development. This will be probably familiar for most of you into software development, the standard software development lifecycle from inception from a product to the deployment or the release from to an application, say to an app store. A product owner or a team defines a product. It will be designed, developed, deployed, and ultimately it will put in production and will put into the maintenance phase. This is the standard software development lifecycle. Now, when in this software development lifecycle usually does a pen test take place? This will be at the last ultimate step. That's where penetration testing takes place. So, does that make sense? Usually, fairly loosely. Sorry?
Before you deploy.
However, then you don't test the application in the live environment. And clients often ask, can't you just test the application on the test environment or a staging application environment, just a fake environment? We always say that actually doesn't make sense because there are always differences in environments, whether it's configuration, whether it's the number of services, even IP addresses, they're never the same, hence the separation in environments. So you actually can only do penetration test, perform it on a live service, which means the service is already live. So penetration testing is actually a final quality control process, but however, the site is already live, the application has already been deployed into production. It's only during the last step. It can also be seen as, which gains some popularity nowadays, is feature toggling. I don't know whether any of you are familiar with it, where you actually enable a feature while it's already in production just by toggling certain flags. It can be seen as a feature which is already enabled. The service is already live, and only then you can test it. So what exactly can you test? Obviously, you can test the technology. Most penetration tests are performed remotely over the internet, so you test stuff like services, applications, that's where you're prod. You can test processes. One example I gave is from incident response teams. Companies want to see whether their incident response team actually detects that there's an attack. So you want to test how my incident response team, how is it working? Is it working as intended? Another example of testing a process would be updating software. There's an issue with supply chain with using third-party software, and the fact that software isn't being updated regularly is actually a process problem. So when you perform a penetration test, when you find vulnerabilities in third parties, outdated third-party software, that's actually a process issue and not a technical issue. You can also test people. An example of testing people would be social engineering, sending phishing emails to people. Another example would be going on site to a client and try to gain access, pose as an employee, copy the badge, walk in and see whether you can actually physically enter the building and then plug in your network stuff and do your magic. However, what is usually being tested, technology, almost always in scope, processes sometimes, people, unfortunately, not often. Yes, we perform penetration tests with physical access, with social engineering, but usually the client says that's off scope, that's going to be too big, it's going to be too expensive, so we'd rather have you focus on the technology. For Black Hat, anything is in scope. I'm originally from the Netherlands, and the Netherlands is part of the European Union. Last year we had the General Data Protection Regulation come into effect. Yay! I think it's a great thing, personally. Last month there was a data leak in the Netherlands. Very good at leaks, probably. This one involved hospital records, and this, as you might know, is quite serious. And when you have a data leak, under the GDPR, certain things go into effect. A timer starts. You need to do things, and the penalties are very high. So this was a serious thing. What exactly happened? Well, there was an employee. of that specific hospital. He went shopping. We all go shopping. However, for that shopping, he made a shopping list. The paper for the shopping list were printouts of medical data. This could be seen as bad. However, it was worse. He left that list, that stack of papers, in his shopping cart. Real story. Happened last month. So that was kind of a big issue. What happened? And to be perfectly clear, I wasn't professionally involved in any of this, so this is more my analogy. Now looking at the case is just from my personal point of view, not from my employer or anyone else. So the root cause, usually when you hear about data leaks, you think about technology stuff, and technology goes wrong. A hacker found a vulnerability, exfiltrated data, that's the first thing you think of, right? In this case, not really. Was it a fault at the process?
Yes.
Why do you think so?
Because he was able to take the printout and take it out of the office and use it as, as a scrap paper instead of shredding.
So there should be a process in place in order to prevent an employee from using.
Yeah.
Yeah. This could be. Once again, I don't have any professional knowledge of the case, but it could be a process thing.
And also, a quick question. How many pages were actually removed?
Multiple.
So it was a big shopping list.
From what I understood, it was stapled together. It could be process thing. People, it's difficult to draw conclusions from just one thing. You don't know whether there was any blank paper available in the office that the employee could use. You don't know any stress the employee was under. So it's difficult to say something about that. But I think it's safe to say that both process and people were involved in this data leak. Technology, I don't think so. DevOps. Who of you here, which company employs DevOps or use DevOps here? Okay, cool. Very good. Not everybody. A little bit about DevOps, what it is. It started out of the Agile movement, rapid stuff. It's seen as a culture movement. There isn't actually an official definition. It's still gaining lots of popularity. It's seen as a set of practices. Once again, there isn't really a definition, so these are some characteristics of what exactly DevOps is. People agree, disagree upon this. Mainly it's about the collaboration between developers and operations. It's more seen as a we together versus the siloed environments we're used to back in the day. One key tenet is that infrastructure is seen as code. So when you want to provision an environment, provision a network or servers, you actually codify that, and using that code, tooling for you will provision stuff in the cloud or on-prem services. So instead of just configuring everything by hand, you codify it and then you let tooling run it and provision your stuff. It's seen as less rigid. Any of you familiar with ITIL? Or more formal frameworks and stuff? It's not really comparable, but if you look at change management process under ITIL, it's a lot of processes. And DevOps is a bit of a movement which tries to break all those silos again and give developers more access, more permissions, in order to make sure that the velocity of change, the time between inception of a product and pushing it to production, decreases sensationally. Really rapid time between inception and deployment to live environments. Then you have the evolution of the stack. Back in the days when you wanted to have one web server, you used bare metal, just a blade or a server. You provisioned it, and that was your server. Then came virtualization. You could run multiple servers using virtualization software on one piece of bare metal. Then came containerization, the advent of microservices, having one business objective codified in one service. And now we're looking at the serverless stack. where you actually deploy applications and your cloud provider mainly takes care of the infrastructure, everything. The only thing developers need to do is push their code and use triggers. An example is AWS Lambda or Azure Functions. And Google, I think it's also called Functions, Google Functions. But this is where everything is going. Who is responsible for execution of security? And with execution of security, I mean securing environments. It used to be system administrators or operators. We had this huge silo, a team of mainly system operators, which knew their baselines, which knew how to provision hardware. They are responsible for it. They had the knowledge, they had the know-how. With virtualization and containerization came the advent also of things like web application firewall. So it became more of a network issue. Is any of you here still using web application firewalls? Yeah. Quite a bit. Because due to the cloud, that changes tremendously, the use or how you can use it or not. And now with the containerization and serverless architecture, you see that the responsibility for actually executing security, implementing it, becomes part of the DevOps teams. So first we had this department where everybody had lots of knowledge about security, about coding, about say standards of ciphers, which ciphers to include. Slowly it moved to smaller and smaller DevOps teams. And those DevOps teams, we still expect them to have the same knowledge as those specialized groups have. And is that realistic to expect from those teams, smaller teams? If you look at tooling, another characteristic of DevOps, if you see the tooling of a generic team, it's huge. Imaging tools, where you use tools like Packer to build images in order to provision it to servers, either on-prem or in the cloud. Virtualization tools, container orchestration tools like Kubernetes or Marathon, Mesos. Provisioning tools, think of Ansible, Puppet, Chef. Configuration management tools, you have the bootstrap issue. When you fire up a server, you want to have that server have certain secrets, so you need some kind of configuration management system in place to provision that server with the secrets, to bootstrap it. Version control systems, Git, obviously Subversion. Continuous integration servers, build automation servers. Jenkins is an example, which is very popular. Travis CI, GitLab. Software repository servers, where you push artifacts. So there are lots and lots of tools that the average DevOps team need to be aware of, need to use. And then each and any of those tools needs its own configuration. Each and any of those tools has its own user management system. If you're lucky enough, it has some, you can use some federated identity management system, so you can use your own, say, Active Directory domain and couple it into, but that doesn't always work that way. Some tools you need to have your own realm, user realm, which you need to configure, which you need to maintain. Then most of those tools also have a plugin system. Say for Ansible, you can use modules. Developers, DevOps teams are able to use any module, build any module, or use any third-party module and plug it in, or with Jenkins or with other tools. So there's this huge ecosystem, this huge responsibility for DevOps engineers, which is now pushed onto them. We expect a lot of them, and is it realistic to expect that? So a DevOps team member, on average, has a huge set of tools and frameworks available, needs to be aware, needs to have knowledge of those tools and frameworks. There's this huge ecosystem of plugins and libraries it can use, and it usually uses. In my experience with companies, DevOps teams, sometimes they have some cross-pollination, they have some vertical guilds or other teams where they share tools, but sometimes you see that each DevOps team uses its own tooling set, which they're familiar with and which works for them, and that's perfectly fine. However, there's lots of knowledge that companies now need to have in order to make sure that everything is secure. On average, a DevOps team member uses more infrastructure assets. And with infrastructure assets, I mean, where usually you had one bare metal server per application, you now have tens of microservices which you use for just one application. It has become really big. And there are new responsibilities, more responsibilities with regards to security. We expect the DevOps team members to be aware of security and to implement stuff. And they have more permissions. Most companies, I get a peek behind the curtain, developers are actually able to push stuff directly to production. So they have the one way or the other those permissions. From the people here who work with DevOps, does that sound familiar? Is that a good thing? I think so as well, personally. I think it's a boon that you see much more cooperation. Whether it's secure, we'll get to that, but on average I think it's a real good thing. However, it does mean more people having access to more critical assets, which creates the perfect storm. And when I say the perfect storm, I'm now in the role of penetration tester. This is awesome. I mean,
excuse me, but also is that, I mean, you're talking about DevOps and not DevSecOps, and even if you have DevSecOps, it's not independent, it's not an assurance. It's kind of like having the pen tester check what was remediated or his own work. So assigning DevOps to be responsible for embedding controls or security controls or being responsible for security is not, it's not independent of that.
if I understand your question correctly,
Yeah.
you're asking, is it valid to ask DevOps team members to assure themselves to implement their own controls and check them?
Yeah. Not. No.
They don't do, even without the secure ops, they're not doing that. You would have users test the app, right? So you test it. So now there's got to be an element where you test the security element, right?
Yes.
So the developers would never be responsible for the testing, right? The results of the testing, someone else would have to do.
Sometimes people see penetration testing as quality assurance.
I guess analytics.
It's difficult.
To be honest, no, it will be just awesome if penetration testing will be part of quality assurance, right? Because you can have a good, insecure product means that it's a bad code, right? We don't have security assurance; we have just a quality assurance. So it should be vital part of the DLC that Microsoft, promote.
It should be part of it. Yeah, baked in. For us penetration testers, once again, it's a perfect storm. Lots of changing technology, new tooling, very rapid, more third-party dependencies. Almost every penetration test you perform, you will find vulnerabilities in outdated software, which aren't patched on time. Less rigid processes, more control over infrastructure, and the knowledge gap. And I think that's one of the biggest reasons when we have this, had this own department with its own security staff, there was just more knowledge. And now you can't just expect everybody to have the same level of knowledge. It's impossible. So from a black hat's perspective, it's changing technology, less rigid processes, and people having more permissions. It's more infrastructure targets to assets to target, more source code, because infrastructure as a code also means that there's more juicy stuff for us to target and more people to target. So the attack surface just widened tremendously thanks to DevOps. Thanks to DevOps, again, from my penetration tester's point of view. Infrastructure assets, targeting changed also tremendously. Usually, as a penetration tester, or as a hacker, I should say, you only targeted corporate networks and their hosting providers. That were how do you gain access to usually using the network. But now you have the virtualization platforms with their own vulnerabilities, the container platforms, the registries. Container registries, for instance, where you have the Docker images, which is now also a vulnerability. Lots of companies reuse Docker containers, official Docker containers, so you can poison those images. Another point of attack for us. The cloud providers. When I say cloud providers, to be honest, I think in general cloud providers are way more secure than your on-prem server. Can I say that here? I can. With regulation, that's a different story, I think. But the massive power that companies like Microsoft, Google, AWS have, can't be beaten. But we also can target the storage service provider, say S3 buckets, Azure storage. And it happens a lot that those storages are unprotected. The orchestration tools. One of the more popular ones, for instance, is Ansible. One could, for instance, for a larger penetration test or as a black hat hacker, look into the Ansible codebase or develop his or her own module. It's all open source. Get a pull request and gain access to networks using that attack vector. The source code repositories. With source code, the thing you see mostly is outdated third-party libraries. I'd all recommend you to go to Pastebin, search Pastebin for your company name, and the times you see where source code has either inadvertently or advertently been shared, or people asking questions on, say, Stack Overflow. Hey, I've got an issue with this and this. Here's my code, and the code you can find, it can be really juicy. You can find lots about the target.
I think the biggest problem actually with the source code is that when developers commit the source code and accidentally add access keys in the code, and before they realize it's
That happens a lot as well, especially now with the advent of more open sourcing software, so that everybody can download the repository. Not everybody is familiar with if you commit something and then delete a file using a commit that, hey,
it's still there.
It's still there. You have specialized tools out there. Trufflehawk, for instance, is a really good open source tool which you can use. You can just download a repo and fire Trufflehawk at it, and it will find cryptographically interesting stuff, such as inadvertently committed secrets. And supply chain issues. You don't actually have to directly attack the target, but you can target, say, for instance, an Ansible module, or make your own Ansible module.
Issues with version control? Version control? There's so much of the issues on the source code with version control.
What do you mean with version control an issue?
I check out from production a module and I modify it, and someone else checks out the same one. And then one gets overlaid over the other. Somehow they're not properly. Source code's lost or something like that. I outline delete some lines, and then I upload that, and then somebody else downloads and has a different version. And there's codes in there. And then they overlay mine, and I have taken it out, and whatever. So version control, more than one person is editing the same piece of code, so you don't end up having the proper testing on one piece of code.
5 minutes. Hopefully your source code system will deal with those issues. But developers have become a much more juicy target for us. They could always read and commit code, that's standard, but now they can publish artifacts. That's the British spelling, by the way.
Did I say what?
And they can access infrastructure. Not only that, they can modify infrastructure. So from a hacker's point of view, developers have now become our juiciest target. That sounded weird. And the times when we perform penetration tests and people are in scope, it's always the easiest way in. whether it's physical or social engineering, sending targeted phishing emails, it always works. What's usually being tested, not people. What's usually being targeted, people. And as an example, this is from this week when Microsoft published a bulletin on a blog post on access from Group A to Group B. How do they gain access? They used account recovery features, asking questions, knowing the answers, social engineering. Another intermezzo. One of the fun things when being a houser is that you travel around a lot. I was at a random airport not so long ago, somewhere, and in that specific area, you couldn't just access the internet. You needed to have some government-issued identification, and then you could scan it, and it give you a ticket, and then you can access the internet. That's the place where you could scan your stuff. Sometimes there were issues with scanning your passport. The machine didn't work. This is one of those machines. And if you look closely, there's a little string attached to the machine, to this particular machine, and it had a barcode attached to it. And apparently it was the master key. So hypothetically, somebody used that code, it worked. So this was a simple way, there was a technical control in place in order to, it should be that I had scanned my passport so that government or, I should be careful here, that you had valid credentials, but it was able to get credentials using a different way around the technology. Root cause was the technology, well, I think actually the technology worked as intended. Was the process? Or was it the person who attached the master key there? So again, technical controls worked probably as intended, but there was an easy way around. Finally, DevSecOps, the latest and greatest movement. It's an iteration of DevOps, actually the newest version. And it basically says that everyone is now responsible for security. Not just more we security people, but everybody in the team. One key tenet is that security is now code. And what does it mean? That instead of having policies and procedures, you should harden this and this, you actually codify it. So, for instance, hardening a TLS server, SSL endpoint, you now codify, you can only use these and these ciphers, it's committed as code, and then it will be provisioned as such. That's a key tenet of DevSecOps. Shift left. You should test earlier on in your development pipeline, not just the last stage, not just penetration testing, but test earlier on. Make security testing part of the pipeline, so not just at the end anymore. And more collaboration, less friction, because still it's an us versus them, us security professionals versus them, the developers, or vice versa. And DevSecOps really tries to make that, try to finally bridge that gap. Some people say, why do we need the name DevSecOps? DevOps, what brings it to the table? It's basically DevOps, yes it is, but only if it brings awareness. Just inserting the free, if only if it brings awareness, then I think it already serves its purpose. The types of security testing, I'm going to increase the speed a bit because I know in 5 minutes there will be drinks. 4 minutes. We have penetration testing. Another form of security testing could be threat modeling. Is it testing? I think it's you can see it as testing. You have static analysis security testing, such as source code analysis. There's dynamic analysis security testing, where you actually run an application on its runtime environment and then see whether it has vulnerabilities or not. And the good thing is that static analysis and dynamic analysis security testing all can be automated, which makes it a perfect fit into your development pipeline. So if you go back, here is penetration testing. In the deploy and also develop phase, you can inject dynamic analysis security testing. An example would be standard vulnerability scanners, such as OWASP, ZAP, or NICTO, which you can run as soon as an application is ready to be deployed. During the development phase, you can use static analysis security testing tools, linters, also to see whether developers try to commit security secrets in their code. And in design and define phase, you can add threat modeling and make it as an obligatory thing when something changes, or each sprint or each X amount of sprints, to insert threat modeling. You can automate testing of code, containers, and infrastructure code, basic security checks, linters. There are various tools available out there that can actually check whether your assets are outdated, whether you're using Node.js or Java or .NET technologies, NuGet. Each and any of those has tools in place, or has tools which you can use, which automatically scan for outdated packages and will alert you, and for instance the build will fail if it uses outdated packages. For containers, you can do the same thing. You can do automatic operating system scan services. Container security scanning is now becoming more and more popular. So each time you use a container or downloaded it, that you do automated security tests, and you prevent poisoned images from being used, because that's becoming a popular attack factor. Generate malicious containers, upload them, and see whether companies will use them. And yes, companies will use them. Infrastructure scanning for your network configuration, standard vulnerability scanning, security baselines. So those are all the things you can automate and should automate. Last advantages: it's repeatable, scalable. You can let a build fail. You can let a build fail when it doesn't pass security checks, and it makes security more visible. I can end on this note.
Well, you ended on a high note. That's good. Thank you, Peter. I'd like to, on behalf of the sponsoring organizations, like to present you with this, I don't know, plaque, whatever, a wall hanging, though there's no hook on it, or a desktop paperweight, whatever it is.
Thank you very much.
For your participation and presentation.